Alright everybody, welcome to another USACO bronze question. My name is Jimmy Ong. I'm a course developer and instructor at Coding Minds Academy. And today we're taking a look at the 2016 February bronze question, circle cross. So here's the question. Go ahead and pause the video and read through it. There will also be a link in the description below. So here's what the question is asking us to do. We're given one long string representing the cow walking into the pasture and out of the pasture. So each letter represents crossing in and crossing out. So our goal here is to figure out how many intersections there will be. So you can see this picture here. The pasture is a circle and the cows are all around the circle. And for this short little string here, AA, BC, BC, we need to see an example of how they'll be walking in and out. So for example, A and A. So A enters here, eats some grass and leaves with no intersections. Whereas B enters here and exits here. And finally C enters here and exits here. So you can see here that the paths of cow B and cow C will cross each other. So now we have a big picture understanding of what the question is asking us to do. Let's go ahead and zoom in and see what it looks like here. So with this example string AA, BB, and CC, we can pretend that this line here will be the zoomed in picture of the entire circle. So here we can start thinking about how and when intersections will occur. So for this example here, how many intersections are there? We can see here that A, B, and C all enter through to the pasture with no intersections. So there's no way for these to intersect. So then that begs the question, when will there be an intersection? So take a look at this example string, AB, AB, CC. And think about how many intersections will there be this time? So this time the answer will be 1. So C has no intersections, but A and B cross over each other. So from this little example, we can see that there will be an intersection if we have this kind of pattern here, this AB pattern. Whereas if two letters are right next to each other, there's no way they'll intersect. So another situation we need to be worried about is if we have that same AB pattern, but maybe there's more letters in between. So for example, we have the AB here, and then we have A, followed by a whole bunch of other letters, then B. So we still have that AB pattern, but there's more things between the exits. And we can see here this actually affects the amount of intersections we'll have. So of course, we know that AB kind of gives us 1 at minimum. So A is right here, then B crosses once right here. But if there's more stuff in between, there's a possibility that there'll be more intersections. For example, this R here. And one could imagine maybe there's like a letter F and letter F down here, and then there's another intersection. So there's a possibility that this AB pattern could give more than 1 intersection. But at minimum, it'll be at least 1 intersection. So here's how we can start solving this problem. What we'll be doing is counting the occurrences of the letters. And we can do this in a stack kind of way, where the first time we encounter a letter, we'll add it to the list. And then the second time we encounter the letter, we'll actually remove it from the list. So the goal of this is to figure out if there are any lone letters. So in this case, we're looking for something that looks like ABA. Right, so that single B in between the two A's denotes that there's at least going to be 1 intersection. So once again, our goal is to figure out if there are any lone letters in the pattern ABA. And we can do that by the first time we see a letter, we'll push it to the list. And the second time we see a letter, we'll remove it from the list. If there's anything left in that list by the end, that means that is a lone letter. So first of all, I'll create a list called scene. Then here I'm going to use a while loop, using indices, using pointers to the last and first position. So this problem is definitely doable in a for loop as well, but you need to be very specific and intentional with your counting variables. I think using the while loop is a little easier, so we'll just keep going until the length of cows is less than 0. And the way we'll iterate is by keeping track of the first and last index and moving those around accordingly. So here I'm finding the first occurrence of the character and the last occurrence of the character. So if this were the case where it'd be AA, they'd be right next to each other. So those don't really matter. There's no intersection there. However, for example, if the pattern is ABA, we'll have a little section we can take a look at. And then the next part is going to be that whole ordeal of the first time we see our character, we'll add it to our scene list, and the second time we see our character, we'll remove it from the scene list. Once again, this is to make it so that we can find any lone letters standing by themselves within this range. So after we process all of that, we'll be left with a list. It may have nothing, or if there is a letter in that list, we know that that is a lone letter, denoting that there's at least one intersection. And finally, this if statement here is checking to see if a pair is not found. So this is after we process the list and after we remove the subsection we just processed. This is the case where after we remove, for example, ABA, we'll remove that, but then the next character is going to be a B. In this case, our code wouldn't work quite as well because the pair is not found. We'd only find the first, but the last would not be found. So then if the last is not found, it'll return a -1. And if that's the case, we just need to inch up our indices. And then finally, this line right here, all it's doing is it's removing the substring that we have already processed.